So students, you watched those two videos, part 1 and part 2 of Newton's universal law of gravitation. You have understood it very well, I hope. Now we are going to summarize the statement as well as the mathematical expression. So Newton's universal law of gravitation can be stated as every object in the universe attracts every other object with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Mathematically, Newton's universal law of gravitation can be expressed F is directly proportional to m1 into m2, F inversely proportional to d square. From 1 and 2, we get F is proportional to m1 into m2 upon d square. Therefore, F, the gravitation force, is equal to G m1 m2 upon d square, where G is the universal constant of gravitation. And you know something, students? The scientists used the same equation to plot the course of a rocket to the moon. What happens to the force if mass of one object is doubled? We have this equation from Newton's law. F is equal to G m1 m2 upon d square. Out of these two bodies, the mass of one object has been doubled. So now we substitute m1 as 2m1 in this equation. New F is equal to G. Instead of m1, you will be writing now 2m1 m2 upon d square. So new F is equal to 2G m1 into m2 upon d square. We already know that G m1 into m2 upon d square is F according to Newton's law of gravitation. So the new force is equal to twice the original force. What does it tell you? When mass of one object is doubled, the force between the two objects is also doubled. Let us see another effect. What will happen when the distance between the two objects, this distance between the two objects, is doubled? Again, we start with Newton's universal law of gravitation expression. F is equal to G m1 m2 upon d square. When d becomes 2d, we substitute this value in place of d squared. So the new force is equal to G m1 m2 upon 2d the whole square, giving new F is equal to G m1 m2 upon 4d square, which can also be written as new F is equal to 1 upon 4 into G m1 m2 upon d square. Similarly, this quantity is nothing but force. So now your new force is equal to 1/4 of F, 1 upon 4 into F. Hence, when distance is doubled, see the distance, the force of gravitation is decreased by a factor of 4. Let's understand the unit of G in SI system. By Newton's universal law of gravitation, F is equal to G m1 m2 upon d square. F in terms of Newton, m1 m2 as kilograms, and distance in terms of meter. So the unit of G becomes Newton meter square per kilogram square. So unit of G is nm raised to 2 upon kg raised to 2 or nm raised to 2 kg raised to minus 2. To find the value of g, we have the expression f is equal to g m1 m2 upon d square. Let us take the values of m1 as 1 kg, m2 as 1 kg and d as 1 meter. We get f is equal to g into 1 upon 1 square, which is again 1. So then force becomes equal to g. Hence value of g is the gravitational force acting between two unit masses kept at a unit distance between each other. The value of g was experimentally measured by Henry Cavendish. In SI units, value of g is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. So students, we end our lesson with this. Please answer the questions and maintain 100 pages long book to write the answers for Science 1. The questions are given after this video. Thank you. See you on Friday.